Wireless apparently is out in the building in case you're trying to get wireless. Those of you at home, I guess, can do your email. Those of you that are here will have to pay attention. Can you hear me okay? Okay, good. So I'm charged with talking about terminologies, taxonomies, ontologies. One of the topics in informatics that usually draws a small crowd, as it is today, but hopefully it can make it interesting for you. Okay, I'm going to talk about rules of terminology. I'm going to talk about good and bad terminologies, the good and the bad and the ugly, and then I'm going to talk about desirable characteristics for control terminologies. And we'll do a quick survey of terminologies, and then we'll look at how high-quality terminologies are enablers of other things like interoperability. And then I'll also take home messages. I'll try and cram all of that into an hour. So first of all, control terminologies. What do we mean by those? We see them all the time in life. In biohealth, we can look at things like the census form, and sorry, I thought I had a blow up on there. Somewhere on the census form is sex, and the answers are not yes and no, they are male and female. So it's a control terminology. It's got two possible answers, so it's the simplest terminology you could imagine. It's just got two things. Any simpler, you wouldn't need a terminology for it. Now you can argue whether male-female is sufficient, and we'll talk about that a little later. But that's a typical kind of healthcare control terminology, very simple one. Here's one a little bit longer. This is a control terminology of charges, probably a mixture of ICD-9 codes and CPT codes and DRGs, but these are then mapped to prices on the hospitalization. And then this is a control terminology. So can anybody read that? No. You can't read that? Okay, so you don't want to guess?
Wellbutrin.
Very good. Wellbutrin. Yeah, that's right. There you see.
Not once a day.
There you go. So slow release. Yes. So it's Wellbutrin. I thought it was Mellaril the first time I saw that. Wellbutrin is correct. So that's control terminology of drugs, and of course it's a little messy, but it's buried in there. Okay. So what about terminologies now? Why do we have terminologies? They're kind of a special value for data types. Okay. So it's not a number, not a date. It's a special value type of a limited set of things that we can say. They can be reused across different parts of the data set. So gender, for instance, or sex can be used in different parts. For instance, it can be used for sex of the children as well as sex of the patient. And diagnosis could be reused as what's your current diagnosis versus past medical history. It constrains what can be said, so that can be a good thing or a bad thing. My audio connection has been lost. Okay, audio connection will not be recorded during this time. Okay, well, that's what you get for not coming. All right, so if you don't reconnect in 5 minutes, this meeting will end. Well, that doesn't sound good. Where's Brian when I need him? Hey, Brian, are you listening someplace? Connecting to audio. Mute yourself. All right, I'm connected, I guess. Okay. Folks at home, can you hear me? You can unmute yourselves and let me know if you can hear me. Somebody typed in yes, I'm seeing yes. Good. Okay, keep yourselves muted and type. That's great. I'll see your questions. What?
I don't think it's allowed to come through.
Oh, I thought he had them. I thought he allowed them to unmute themselves. In any case, that's good. All right. Constrain what can be said, which can be bad because maybe you want to say something the terminology doesn't allow, but often it's good because it makes sure that what you're saying is said in some formal, consistent manner. That's this. Okay. Whoops. And so it provides that consistency for what you can say. So let's take a look at gender. Why do we want to have it in a controlled form? One reason is that we want to reuse the data for other purposes. So imagine a patient comes in the hospital, 50-year-old Native American female, is what's written in the record. We put it in the EHR, but then we might transfer that over to the admission discharge transfer system, which can then do things like put the patient in a female bed because the patient's a female. So that's a reuse, a very simple reuse. How does the computer know the patient's female? Well, we said the word female, so that's easy. But it could have said something else. It could have said female with uppercase F, which to a computer is not the same thing. That capital F is different, but it has you can tell it will ignore case, and then it will do that. But this is also different, and this is very different. Okay, so all of those things may be synonymous to the computer, so that says if I see any of those things, I know that it's female. And what if it's, you might even say that, and if you're at a children's hospital, maybe we'd say that. And all of those could be translated to the concept of female. Okay, so a few definitions. A term is a word or phrase associated with a specific concept or meaning. So the thing in our head is the concept or the meaning. And the term is just the name that we give it. That's a thing that typically a human being could read, could say to somebody else. We don't do mind meld, so we have to transfer information by spoken and written language, sign language, what have you. But the term is the name that we attach to these things, and the concept is what we have in our head. Terminology is a collection of terms, and it's also a finite enumerated set, and it's done so that it can convey information unambiguously. Okay, and that is, as opposed to a vocabulary, which is just a collection of words, this is a set of concepts. Okay, ontology, another term you'll see, is a formal representation of knowledge, and in these days when we talk about ontologies, we're usually talking about hierarchical arrangement of concepts for a particular domain that has other information, other properties about those terms, often things like their definition. So knowledge, an ontology is a collection of knowledge. Today we talk about ontologies that are knowledge about terminologies. Okay, some basic terminology features are that they will typically have a code associated with them. Sometimes it's the name, but usually there's some kind of code, a number, or a mixture of numbers and letters. F could be a code for female. They'll have an official name or a canonical name like female, and then it may have synonyms, other forms that we can say if the person typing it into the system or somebody we encounter this term in or this word or phrase in a text document, we can map it to the concept female with code F. And then terminologies may have other things in them as well, like cross mappings to other terminologies. So ICD-10, ICD-9, now we have cross mappings between them. And so you may say, I've got a problem with terminology. I want to know what the ICD-9 codes are for those problems. Pharmacy drugs will have NDC codes and so on. And then there may be semantic relationships. So these are non-hierarchical relationships between terms that convey other meaning. So for instance, we might say drug ingredients. So drug ingredients are chemicals, but the drugs are sort of products or manufactured objects, and so they will have a relationship between them that is has semantics or meaning associated with it. We might talk about substances measured by a laboratory test in a similar way. And this is an aspect of ontologies, kind of separates them from vocabularies and terminologies. So if we had time, I would have you actually create a control terminology for gender. Okay, so you have this task that you have to have a list of codes for things that people want to say on the census form. Very simple, 1, 2, that's it. We just say, these are your choices, 1 or 2. What if we wanted to have more choices, or we wanted to be, so everything that somebody could put in, we want to have some kind of a code for that, for every different concept that you could convey. Okay, so what strings correspond to those codes? What would the codes be? How would you organize them into some kind of useful set? So we don't have time to let you do it, or guess how many you need. I did it with my class once at Columbia, and we came up with 76 different things for gender. So it's not a simple task, but I'm going to give you a simple example, and we can kind of critique it a little bit. So this is my terminology. It's arranged in a hierarchy. There are numeric codes, and there are text names for each thing, and then that's my terminology. So I've got 3 sort of top-level terms, male, female, and other, and then I've got looks like 6 other terms, so a total of 9 terms in the terminology. Anybody want to tell me what's wrong with that terminology? Well, got to be specific.
Well, so male. So what's a child? What's a boy?
Okay.
You know, so I guess you could age delimit them.
Right. So I didn't say what I didn't give you definitions. Okay.
So certainly, and you're just saying, and you don't have a comparable female. I mean, just
Okay. So it's incomplete.
Female that you have a parallel.
Right. So it's incomplete. I'm missing female child. Right. What else?
The garbage can collection.
Sorry?
Yeah, the garbage can collection for other.
A garbage can collection for other. Okay. Do I need it? Maybe sometimes you need a garbage can. What if somebody says they're a true hermaphrodite? Is that a male or a female? What? I mean, it's neither, right? So I'm trying to put it somewhere else. So I could call that non-male, non-female or something like that, but the idea is that it's something other than male and female. What else? So I'm not going to give you points for that one. So what else?
Female transvestite.
What about female transvestite?
Well, it could be a
It could be what?
It could be.
All right, so that's another example of incompleteness. There's a lot of incompleteness. So let's go to a different problem. What else is a problem on this terminology?
So do you have, I don't know about your capitalization or how you're let that all be blocked out and not worry about capitalization?
Yeah, that's okay.
You got that.
I'm not going to worry about that. No.
We don't have something that's non-binary. I mean, that's a terminology that people are using right now.
Sorry?
Non-binary.
Oh, non-binary?
Correct.
I've never heard that term. What does that mean? Does that mean
that the person doesn't
uncommitted
want to
or
go by male or
okay?
female.
So incompleteness. Still, so let's get away from incompleteness.
Okay.
What else? Because I don't have transsexual, right? I have a lot of things that are not on there. What else? What are other problems with this terminology? So you're saying, this is the 20th century solution is we make this terminology better by just adding more things to it. Okay? That would make this, that's in the 20th century, that's how they made terminologies better. I contend that this terminology has other problems that will not be fixed by simply making it bigger. Anybody else?
Can we have an option that's just transgender? So number 10.
That's a completeness issue.
Okay,
Let's get away from completeness and talk about other
so putting a
problems.
text field where people can say what they are is an evil thing, I know.
No, so no, that's an interface problem. Here's a control terminology. I'm trying to anticipate what people would write in that box. Okay? So, what else?
If I educate you as to what people really think they are, they self-identify.
Right? Yeah, but I'm trying to, then I want to encode those things. I want to have a control terminology so that I can code all the things, so I can gather people together that all have the same answer without using what they wrote in.
Your numbers are not hierarchy. No.
The numbers are arbitrary. Meaningless identifiers, I'll get to that. There are hierarchical coding systems. That's actually a bad thing, so I'll show you why. All right, so how about having the fact that I have a code for male child and I have a code for boy? Okay, typically considered to be synonyms, right? So I have redundancy. I have two codes with the same meaning, so that's a bad thing. All right. What about male transvestite? Is it really other? It's kind of male, right? So I've misclassified that. Do we have any spelling champions in the audience?
There should be
There is no other than trans.
What?
There should be an S.
Yes, transvestite is misspelled. Okay. So let's see what else is there in there. Did I have any ambiguities? I was kind of ambiguous about what the range of age for child. That's because I don't have that first. All right, let's move on. I don't have time for the whole thing. Oh, unknown. I forgot about that. So unknown. Unknown is something that you fill in sometimes because you don't have one of those other answers to put in. But it's ambiguous because unknown could mean nobody told me, so I've got to put something in here. So blank means unknown or whatever. I'll put a code in there, 99 or something like that. Means unknown. But unknown can also mean, gee, we looked and we couldn't tell. And that actually happens in newborn children, right, where their genitalia is ambiguous, and so you have to do some other kind of test before you figure out what gender they are, at least genetically. So unknown is an ambiguous term. So we've got ambiguity, we've got incompleteness, we've got redundancy, we've got misclassification, and so on. This is a bad terminology, okay? So now what we want to do, if we want to have a good terminology, we have to know how to characterize a bad one so we can know how to move towards a good one. Okay, so what happens if it's poor? We can't record our data. The data meanings are unclear. If something, we may make a mistake in inferencing, especially if things are classified wrong. We might order the wrong test, or we might interpret it incorrectly, or order the wrong treatment, or put the patient in the wrong room. Okay, so isn't this problem solved? It's not solved because everybody goes out and builds their own standards because it's easier to use your own standard than something that was NIH, not invented here. Okay, because you look at it and go, well, that's not quite what I need, or I don't really understand it, heck, but I'm just going to create my own. There are standards, but they are not agreed upon, and they're not good interlingua, not good ways to translate between standards that avoid loss of meaning. Maintaining terminology costs money, so oftentimes people will create a terminology and walk away from it, and it quickly becomes out of date. Sometimes there are proprietary interests that prevent the dissemination and adoption of terminologies. And really, the modeling terminologies in a way that actually helps the computer with its symbolic manipulation is difficult to do. So in gender, what do I mean by gender? I didn't even tell you what I mean. Do I mean what they look like because I'm going to put them in a room with somebody else and then want them to think they're the same gender, whatever that is? Or is it genetic? Do I care about their genetic gender, or do I care about their physical characteristics. So a male born with testosterone insensitivity syndrome is a male, but they are raised as female with estrogen because they don't respond to testosterone. But do they get uterine cancer? No. Do they get breast cancer? Actually, I have no idea whether they get breast cancer at the female rate or the male rate. We're going to have to look that up one of these days. So what do we care? Why, what do we mean by that gender? What's the purpose of it? It could be administrative. What room do we put it in? 99% of the time we know they go in this room or that room. But 1% of the time we go, you know what? It's in a single room. So we're not quite sure where to match it up. Okay, so a little history. 1994, there was a conference sponsored by the International Medical Informatics Association. This is Mont Pelerin in the Hotel Mirador in Mont Pelerin, Switzerland. That's Lake Geneva. And they had a conference on controlled terminologies. And a bunch of people got together and started presenting things about how to represent controlled terminologies. And the guy who chaired that meeting, General Chiret, asked me to write a paper about it to summarize these things. And I ended up writing a paper that I presented then at the next meeting in 1997, which was in Jacksonville, Florida. This is the Ponte Vedra Beach Hotel. They have great places for these conferences. I presented this paper called Desiderata for Controlled Medical Vocabularies in the 21st Century. And that accounted 12 different desirable characteristics or desiderata for controlled terminologies. I'm going to go through those very quickly just to give you a flavor of this. So content is, obviously your terminology has to have the things you want to say. If it's incomplete, that's a bad thing. So content's important, but just adding terms doesn't work. You can just, eventually start messing up. You start adding redundancy, you start mixing up the classification of the terms. So just adding terms is not enough. You have to figure out what's the breadth and depth that you're trying to cover for your domain. And structure, you have to be careful that the structure of your terminology doesn't prevent you from adding more terms. And if you look at a terminology like ICD-9, it runs out of room. So they created ICD-10, and it will run out of room because of its structure. So informal editorial policy and methodology for adding terms to a terminology is critical. Concept orientation is the most important desideratum. That is, the unit of discourse is the meaning, not the term. Okay, it's the thing. We can change the name of the term if we have a reason to, but the meaning has to be something that we hold constant. Non-vagueness, there should be a meaning for a term, but it should be no more than one meaning. It should not be ambiguous, and there should not be more than one term per meaning. That would be redundancy. You don't want two different ways. You don't want to have one code for girl and one code for female child, and then half the people are using one code and half are using the other, and you say, okay, find me all the records of female children, and you're only going to get half the records because somebody used a different code. Explicit synonyms are fine. Explicit synonyms are good. So girl and female child can be synonyms of each other, and one of those could be the formal name for the concept, or you can have some other thing if you wanted, but that way you map those things to a single meaning. Concept permanence goes along with concept orientation, because once you create a concept, you've identified a concept, start capturing data with it, you can't just delete it. Okay? An example of that is non-A, non-B hepatitis. So we don't use that term anymore, but we used to use it when we did not know about hepatitis C and didn't know about hepatitis G and H and Delta and E and all these other things. We use non-A, non-B hepatitis. It's now an outmoded term. But we can't delete it. If we forget what it means, we're going to go and find data on people who died of this. And we can't say, oh, they must have had hepatitis C. We don't know that. They could have had something else. So they had a condition that at the time we called non-A, non-B hepatitis, which now we don't use as a modern concept. Terms can change as long as the meaning doesn't change. So retronyms are an example of that, and one of my examples is transvenous pacemaker. So it used to be all pacemakers were transvenous, and then we have transcutaneous pacemakers, so they had to go back and say, oh, that's not a pacemaker, that's a transvenous pacemaker, to make sure it was clear what we meant. But we didn't change the meaning of it, we just made the name more descriptive. Non-semantic identifiers. So a lot of times in coding systems, people like to give numbers that have hierarchical meaning, or they want to give short names like mnemonics for the codes, and that seems very appealing, but you run into trouble. If you use the name, then you can't change the name, because the name is the code. So if you change the name, you've deleted an old code, which you're not supposed to do, and you've created a new one, which is redundant. You don't want to use a mnemonic for the same reason. And also, people will mix up the mnemonics. So the laboratory will call it glue one day and Gluck another day, and then you're never sure whether they're talking about glucose or glucagon or what they mean. So a meaningless identifier, don't use a code that'll run out of room. Like say, oh, a 4-digit number. I'll show you an example where that becomes a problem. And don't use a hierarchical code. Again, I'll show you why that's a problem. So a meaningless integer tends to be pretty good with a check digit maybe, so that if somebody types it in and they screw up the code, you can do a little mathematical calculation. You go, there's something wrong with that code. Like your credit card number. If you put in your credit card number, there's a formula. I don't know what it is, but there's a formula that will say there's something wrong with that number because the last 3 digits of your credit card are a check digit based on the rest of the numbers. Okay, polyhierarchy. So strict hierarchy, we saw the gender example. Polyhierarchy is where things can have more than one parent. Although you don't want to have any cycles, but you may be able to say something has more than one parent and has multiple names, like directed acyclic graph or DAG or partially ordered set, and so on. It's useful for understanding the meaning of the term by seeing where it's placed in the hierarchy. You can tell the meaning of that term. It's also important for tree walking, where you say, well, I have a general term, and now I'm trying to find a more specific term. So the example in drugs, for instance, you might say, well, I know it's a Tylenol compound. It's Tylenol with codeine, so I'm going to walk down hierarchy. Here's Tylenol. Let me go down until I find Tylenol with codeine. That's fine, but then if you walk down the codeine hierarchy, you want to make sure you find it under there too. And that's the idea of a multiple hierarchy. Is that a question back there? Nope. Okay. Feel free to interrupt with questions. You folks at home too, I will see you when you raise your hand, I think. Or at least I'll see a comment. They'll pop up on the screen. Okay, and needed for inferencing. So if you, again, taking my Tylenol with codeine example, if you say, is the patient on codeine, and you say, find me all the descendants of codeine, and Tylenol codeine isn't there, but is over in the Tylenol tree, then you're going to make a mistake in inference. Show you an example. Goodpasture syndrome. Goodpasture syndrome, an autoimmune disease that antibodies that affect the basement membrane of the liver, the lung and the kidney. Okay, so we have a disease hierarchy. We've got heart disease, lung disease, kidney disease. Goodpasture syndrome is a kidney disease, and these arrows pointing up mean ISA. These are hierarchical relationships. So Goodpasture disease Goodpasture syndrome is a kidney disease in a strict hierarchy, but in a multiple hierarchy or polyhierarchy, we can say it's also a lung disease. Okay. While we're drawing graphs, let me just show you a semantic network, which has not only hierarchical relationships like ISA, but has non-hierarchical semantic relations like has site. So we can say lung disease has site lung, kidney disease has site kidney, and Goodpasture's disease has both of those, which it's inherited through this semantic network. We can also say there's a finding hierarchy, and Goodpasture syndrome may have both. Hematuria and hemoptysis, which are explicitly related to that, not inherited. And we'll come back to that when we see some of these more modern terminologies. Formal definitions are knowledge about the meaning of a term that's included in the terminology. It's typically provided not as a text definition, which you're familiar with in dictionaries, but a formal definition which has a structure to it, a formal structure, and uses controlled terms for expressing the information. Supports understanding, like that's what a definition does, but it can also help you with maintenance. So the computer can say, if you put in definitions of terms, it can help you, for instance, with organizing terms in a hierarchy or detecting redundancy, that sort of thing. And so you can represent it as relationships within the terminology or to terms in another terminology. So I'll give you an example in a second. And we talk about representing definitional knowledge, which is about the meanings of the terms, as opposed to other things we might assert about terms. So we can say that a penicillin tablet includes penicillin, and we can say that penicillin is a treatment for a disease. Well, the treatment of the disease changes, right, as our knowledge changes or as the disease itself changes. And so that's assertional knowledge, or we might say, what's the price of a drug, or we might say, but when we say what's the ingredient of a drug, that's part of its definition. If we say what causes pneumococcal pneumonia, it's pneumococcus. It's not going to change. What's the site of pneumococcal pneumonia? It's the lung. That's not going to change. So those are definitional things that are much more permanent. So here's an example of a narrative definition for a lab test. Serum potassium test measures potassium ion concentration in serum, and then we can have a formal definition where all of these pieces are controlled terms. ISA is controlled, has specimen is controlled, measure substance are all controlled terms, and then the values of those attributes are also controlled terms from the terminology. And graphically, we can depict it like this. Okay, and I think this is the last one I want to talk about, not else or classified. So not else or classified kind of means other. It's a category that we use, and Tim mentioned sort of garbage can category. This is to be avoided as much as possible, and there's some good reasons for that. NEC or not else or classified. It's used for concepts where you don't have an explicit code for the term or an explicit concept for the term, and so you sort of say, well, it kind of, we'll use this other thing because we need to put it somewhere. You can't have a formal definition. It's very hard to define something that is where its meaning is not everything else in the universe. All right, it gets a little complicated, and you can do it once maybe, but as soon as you have two things and go, well, I'm not everything in the universe including you, and this one I'm not everything including you, it gets a little complicated. And it can change. The meaning of these terms changes as the rest of the terminology changes, because if my definition is based on the rest of the terminology and that changes, then it's you have semantic drift, and I'll show you an actual example of this. In 2007, if you, and this is data, I'm using data from the Clinical Center at NIH, you could have 3 different diagnoses for shock or non-traumatic shock, cardiogenic shock, septicemic shock, hypovolemic shock. If you were coding an ICD-9 in 2007, there was only one code for that, the cardiogenic shock, 785.51. The others, you had to use shock without mention of trauma, 785.59. So that was the shock, not S1 classified for those two things. In 2008, they added the term septic shock with 785.52 as its code. So now you could code septicemic shock with the septic shock code. Hypovolemic shock still had to be coded the old way. So when you look and say, oh, how are we doing on curing shock or preventing shock, you look at the cases of that, and so we can say, okay, there's my 785.5. That's actually, they shouldn't even be using that code because it's an upper level code. But there's 785.51, so there's my cardiogenic shock, not too many cases of it. And there is shock not else or classified. And it looks like we're winning the war on shock not else or classified, right? But we're not, because what happened is in 2008 they started coding with this other code for the septic shock. And so that sort of appeared, and we see, though, it looks like we're fixing that. And that's actually a phenomenon that's called the Will Rogers phenomenon. Will Rogers wrote that during the Great Dust Bowl era, when the Okies moved from California, the IQ in both states increased. So he managed to insult everybody at the same time. Okay, so let me see how we're doing on time. Probably terrible. Yeah, 10 minutes behind already. All right, so I'll just talk faster. Terminologies, lots of terminologies to choose from. I'm going to go very quickly through some of these. International Classification of Diseases is maintained by the World Health Organization, and there are local extensions to them. ICD-9-CM, ICD-10-CM are the ones that we're familiar with in this country, and there are others. It violates pretty much every desideratum there is. It's got not otherwise specified terms, which are fine. Those are just upper-level generic terms, but it also has the dreaded NEC. And we have these local extensions in the U.S. and there are others in more countries. Just to give you a sense of the size, the ICD-9 had 8,000 terms, ICD-9-CM had 14,000 terms. ICD-9 came out in 1972, ICD-9-CM came out in 1979, ICD-10 came out in 1982, ICD-10 in 1982, and then we got ICD-10-CM in 2015. So a huge lag between when 10 came out and 10-CM came out, and they're already working on 11, so who knows when we'll get around to ICD-11-CM if we really need it. But ICD-10 was created, and a much bigger terminology, uses letters and numbers, which is great. So now when you see a circle, you don't know if it's an O or a 0. And when you see a vertical line, you don't know if it's an I or a 1. I mean, whenever I would talk about this, and anybody from the World Health Organization was in the room, they would leave when I got to the desiderata because they didn't want to be questioned about why are you violating the desiderata. All right, so just show you some quick examples, and this is I'll give you an example of why. So I've already knocked the NEC codes. Now let me knock the hierarchical coding. So if you were in ICD-11, there were like 450 codes for tuberculosis with different codes. They stripped it down in ICD-10. So there are 51 codes, terminal codes or leaf node codes, plus 10 hierarchical codes. And I'm not going to go through these, obviously, but we can see there's, tuberculosis of the lung, A15.0. So that's, pretty clear. And then tuberculosis peritonitis, A18.31. So you can say, you know what, I'm noticing that if it begins with an A15 through an A19, those are all tuberculosis. So if I'm going to find all the cases of tuberculosis, just gather those codes up. Wouldn't it be nice if they had a super class of those, but that's fine. I'll make my list of 6 codes or 5 codes and pull those together. The problem is it lures you into a false sense of security, because elsewhere in ICD there are 13 other tuberculosis codes. Some are sequelae of tuberculosis, some are complications of pregnancy, and then there's 3 sort of isolated ones that are coded by the complications of pregnancy hierarchy, not the tuberculosis hierarchy. And that's what happens when you have a strict hierarchy. You got to choose. So that's the polyhierarchy. So why do you want to do this? You want to record data that's clinically relevant at the clinically relevant level of detail. The intended meaning should be clear. You want to reuse the data. You might have to recode it in some other terminology. That's okay, as long as you don't lose the meaning of it. Terminologies, variant suitability. And if you look at ICD-10 compared to ICD-9 or other terminologies, it doesn't really help. It violates all these desiderata. What do you do if you want to capture ICD data with ICD-10? Well, the answer, yes, this is, I'm going to skip through this because I've already beaten on it enough. The answer, what do you do? Capture the original text first. Second, code the data with a suitable terminology for coding the data you're collecting. If it's clinical data, use something much more detailed. I'll talk about SNMD in a minute. And then you allow free text modifiers. So if your decode isn't explicit enough, use a generic code or more general code, and then don't say NEC. Include the modifiers from the original text so you know how it's different. And now you can distinguish it from the general one because it's got a modifier, even if it's uncoded. It doesn't really matter. I mean, what are you going to use? Pneumonia not elsewhere classified. How does that help? How does that help? What are you going to do? Say, oh, I better use antibiotic not elsewhere classified, right? I mean, it doesn't make any sense. So capture those free text modifiers. Later, you may be able to map them to a more specific term, but at least you haven't lost the meaning. And then map your data to ICD-10 or whatever you want. Render unto Caesar what's Caesar's. You got to report to the government. Fine, but maintain your original data for the clinical purposes, and keep all this stuff in the source of some sort, so you can figure out how they map from one to the other. National drug codes, NDC codes. These are the codes currently used for coding your drugs. If you look at the label, you'll see this multi-part code. There's a 4 or 5 digit code for the label. It used to be 4, but they ran out of room, so they made 5. Then they said they have a 3-digit code for the, that was the product code, which the labeler, whoever's selling it, gets to call for the product. Then there's the labeler code, which is assigned by the FDA. It used to be 3-digit, then they got more than 1,000 labelers, so they went to 4 digits. And then there's a package code that tells you is this blister pack, 100 tablets per bottle, whatever, and that's 2 digits, also determined by the labeler. And codes can be reused, which causes no end of confusion. So here's an example of 2 records from the FDA. They actually have, excuse me, a unique identifier for the drug 3412. But we can see this is nitrostat tablets, 100 in a bottle, and we can see 0071, so that's the product code. Then we see 0569, that's the labeler code. And then we see 24, and the next one, that's the package code. So altogether, that's the ICD-9 code for that thing. Now, you run into trouble when people go, well, those hyphens are annoying. Let's get rid of the hyphens. Well, when you do that, now you can't tell whether you had a 4-digit product code and a 3-digit labeler code, or a 5-digit product code and a 3-digit labeler code, or where they were 4 digits each. So you could actually parse that 2 different ways. And then they say, well, those leading zeros are a pain, because if we get rid of those, then the data entry form can go, just check to see if it's a real number, because that's an integer, and that's a legal, we can check that very easily. But then, of course, you run into more problems when you try to figure out which code it is. And there are actually drugs that have those different codes that are completely different, but expand them. So they run into trouble with their coding system and the ability to reuse them. The replacement, which we're trying to move to, is RxNorm. RxNorm was developed originally by HL7 and picked up by a number of other groups, including the FDA, National Library of Medicine, and others. And the idea was to create actually an ontology. This is a graphical representation where each concept has a unique concept identifier, a meaningless number with the letter C in front of it, and then actually all kinds of semantic relationships that relate things to each other. And it's kind of interesting because I didn't know there's 2 different kinds of diazepam, brand name diazepam, Valium and where's the other one? Solus, I think it's in there somewhere. And so, yeah, Solus. So they actually have codes for all these things, and they have codes for Valium, a brand name. They have codes for diazepam 5 milligrams, which isn't even a pill. It's just sort of this notion of 5 milligrams worth of diazepam, and that's the ingredient of a 5 milligram diazepam oral capsule. It's very handy. And of course, the concept of diazepam, the chemical, is in there too, but that's not part of RxNorm, that's part of another terminology. Okay. LOINC, logical identifiers, names, logical objects, identifiers, names, and codes. Originally it was supposed to be laboratory, and they expanded it, and the idea is the HL7 needed codes for laboratory tests. They got this one field, and they wanted to say, listen, we all should have the same codes when we fill out our HL7 messages, and the original idea was to have self-defining names. So you had this multi-part name that would tell you exactly what the thing was. I'll show you what that looked like. There was the first part was the component, which is the thing the test measures, and there's a few other things we don't have time to talk about. There's the property, the aspect of the component that is being measured. So is it the weight, is it the mass, is it the concentration, is it the length, is it the time, properties like that. Timing, how long is the time, what is the time of the test? Is it an instant, like a blood test, a point in time, or is it a 24-hour urine collection, so where it's 24 hours, that sort of thing. The system, they have funny names for these things. So the system is sort of the specimen. What part of the body did this come from? Or did it come from swimming pool water or the cafeteria food or whatever, but it's the specimen. And then the scale, the level of precision. Is it numeric? Is it qualitative? Is it a fixed set of terms? Is it ordinal, like +1, +2, that sort of thing. And then sometimes the method is in there as well. And when you put these all together, you get these multi-part names. There's the code. They use an identifier plus a check digit. And then you see glucose, post 100-gram glucose. So that's what's being measured. Substance concentration. PT is point in time. Seroplasm is serum or plasma. That's the system. And then QN is quantitative. And then we've got another one that looks almost the same, except it's now mass concentration. So instead of reporting millimoles per deciliter, it's reporting milliequivalents or milligrams per deciliter. So it's mass versus substance. And it's got a completely different code because they're meaningless identifiers. And then we can see some other examples of how these things come together. All right, SNOMED CT. SNOMED, Systematized Nomenclature of Diseases and Organisms. SNDO was started in 1928, and it's evolved over the years to SNOP for pathology and then SNOMED for diseases, and eventually it is now SNOMED CT, or SNOMED for clinical terms, after a merger with the Reed clinical terms from England. And it has a semantic network, it's got definitions, and there's a US-wide site license, so we can all use SNOMED for free, which is saving us hundreds of thousands of dollars each. And it's maintained by a group called the International Health Terminology Standards Development Organization, or ITSIDO. And I have to tell you a story. So there's a follow-up from this meeting. So this is the Carambola Beach Resort in St. Croix. And in, what was the year, 1998. So Desiderata came out in actually presented in 97, it was published in 98. And shortly after publication, I was invited to this meeting of the College of American Pathologists at this beautiful resort to talk about the Desiderata. The problem was it was a 2.5-day meeting on terminology, and I was the last person on the agenda, and everybody's looking out the window the whole time at the beach, and I'm the last person on the agenda. So the guy who was running the meeting, Kent Spackman, I said, listen, you really want me to spend half an hour on this? He goes, well, no, it's important. You know, take your time. So I presented all that I just did in 5 minutes. And they said, well, why are we hearing about this? And Kent said, well, I'm hoping that we can adopt the Desiderata for SNOMED. Somebody goes, I move we adopt the Desiderata. All in favor, aye. Okay, motion passes, meeting adjourned. And they went out to the beach. But Kent stayed behind. And Kent changed SNOMED from a really crummy terminology to a beautiful terminology by applying the Desiderata. And just show you some pictures, some images. I won't show you how bad it looked before, but now it's got semantic definitions. It's got a multiple hierarchy. This is an example of pulmonary tularemia in SNOMED and how it's related to other things in SNOMED. By the way, this is where they meet now, the SNOMED editorial board now that ITSIDO took over, and they're in Denmark. That building in the left and the back is a 4-star hotel in Denmark. At least it's priced that way. But that's the view. So I'm glad I got out when I did. Okay, so medical subject headings, you may be familiar with that from the National Library of Medicine. They use it to index the medical literature. Just a screenshot. I assume you guys will all have these slides so you can look at them at your leisure. And the Unified Medical Language System. So let's see, am I talking fast enough? Almost talking fast enough. So the Unified Medical Language System was created by the National Library of Medicine to bring all these things together. Don Lindbergh in 1986 more or less said this quote. It was published in 93. But he said he wanted to help computer programs understand the biomedical meaning of things users were typing in to help them get to the information they needed. 1986, there were now lots of knowledge resources that were starting to become available, and they used different controlled terminologies. And the idea was, how could we start with one like mesh and get to the things that would be in these other resources? So they created the UMLS. And the idea in the UMLS was to take all these terminologies and get all the terms or strings, character strings, bring the strings together, give every string a unique identifier, or SUI, string unique identifier, and then find the strings that had the same meaning and group them into concepts and give those concepts a unique identifier, or CUI. And they really talk like SUIs and CUIs, and they have LUIs for lexicals and AUIs for atomic. They have all these unique identifier things, and they really talk like that at NLM. And then you group these things into concepts, and you could relate them to each other based on things that you infer from the original terminologies. So if the term heart in one terminology was related to the chest as a site, then we have the concept heart. We can say, okay, the concept heart is related to the concept chest, or pneumococcal pneumonia is related to staph, to pneumococcus, and so on. And it's grown. I just have the statistics back to 1999, but back in 1990, 1990, it had only one source, and it quickly grew to all these other. We see all these different sources and the codes, and so we see now, what are we up to? Number of strings, 11 million strings. They must have got rid of some. I'm not sure what happened in 2016, but the number of concepts is over 3 million concepts, so it's big. And it's these big ASCII files that you can download and put into your own database. This is Mr. Conso, and you can see the concept unique identifier, and you can see, so there's the CUI, and there's a LUI, and there's a SUI, and somewhere in there you can see the string benign neoplasma heart. These are all strings for the same concept. So the concept, the preferred form of this concept is benign neoplasma heart. It has a PF, that's how we know it's the preferred form. And then we've got other ones in English. We've got there's a German one, a Spanish one, and we can see all these different terms here. But these are just different ways of, spelling tumor with O-U-R as opposed to O-R, and so on. All those are from all different terminologies. There's also files like, let's see, your audio connection has been lost. If I click on it again, what happens? Connecting. I don't know what's doing that. Must be this wireless thing. Maybe if I'm walking away. Okay, I don't know what's going to happen. Connecting to audio. Ryan, are you out there somewhere? Of course you can't hear me because it's not connected to the audio. All right, well, I'm going to make you guys showed up, you get to watch the lecture. All right, MRL or Mr. Rel is another file that contains the relationships between the concepts, and these are fairly simple. If we say, here's 15, 153, 957, that's the benign tumor of heart. And somewhere in here we could say it's connected by location of, and it's related to 18787, which I happen to know is the unique identifier, is the concept identifier for heart. So it captures all these things in these big files. You can download them for free. All right, UMLS, not a terminology. If somebody says, I'm going to use UMLS for terminology, correct them immediately. It's not a terminology, and if you try to use it as a terminology, it would be a disaster because it's full of all this near synonymy. There's no formal conceptual model for everything in the UMLS. There's some semantic network and some other things that approach that, but because every source terminology, they often have no conceptual model. Now you're taking all these terms and pushing them into a big pile and trying to figure out which ones are synonymous, and it's mostly hopeless. It's good for a few things that I'll show you, but although they're hierarchical relationships, there is no single hierarchy for the whole UMLS. And in fact, you can find cycles because one terminology says this concept is related as a child of this concept, and others will say it's the other way. And so when you put them together, now you have a cycle. There's lots of those. There's a lot of redundancy because, try as they may, they got 3 million concepts. It's really hard to figure out when you add the 3 million first concept, making sure it's not synonymous with some concept that you already have. Back when it started, when they had 16,000 terms, 30,000 terms, they actually tried to manually review these things. They would map them lexically and then review them and remove the mappings that were incorrect. So when nursing home and home nursing match together, they go, oh no, those aren't the same thing. Or pelvic kidney and kidney pelvis map together, they go, oh no, those aren't the same thing. But now there's no way they can manually review all those things. Lots of ambiguity, but that's because the terminologies are contributing ambiguous terms. So in 1998, Betsy Humphreys wrote, UMLS supports development of user-friendly systems to effectively retrieve and integrate relevant information from disparate machine-readable sources. A much more modest and accurate description. Okay, uses of the UMLS. We can use the UMLS to reconstruct source terminology. So if you're trying to find ICD-10 or ICD-9, you can go to the UMLS and just go, get me all the records in Mr. Conso that have that ICD-10 in that right field, and bang, you got everything you need. It's actually good for finding synonyms for a particular source terminology. So you can say, well, I'm interested in, say, ICD-9 or ICD-10. I want people to type in names that are going to map to ICD-10. I can take all the synonymous terms from the UMLS that map to the same CUIs and say, oh, well, if this term is mapped in this CUI, then all the other terms mapped to this CUI are supposed to be synonyms, so I'll make them synonyms in my lookup table. And you can use it for automated translation, although it becomes tricky. So you can translate from one terminology to another through Mr. Conso and say, hey, if this term maps to here, find me a term in another terminology, the target terminology, you can do that. But as soon as you go away from the one-to-one mappings, you start looking at things like Mr. Rel. Well, there's no one-to-one mapping, but let me see what other relationships. Oh, well, there's a broader term. I'll try mapping to that. But what if there's two broader terms? Which one do you pick? Or are they anded or ordered? What do you do? It becomes complicated. Okay. How are we doing on time? 11 minutes. All right. Issues in cognitive information processing, communication practice, education, research. So these are all questions, and I'm not going to go through all these. But these are questions that you might want to have a computer do with electronic health record data. And if you coded your data in some formal way, you might be able to build an application that would do things like figuring out that if a patient has a particular allergy, that you shouldn't give them a particular drug, or figure out that how you would bring in an expert system to help you do differential diagnosis by looking at the findings that the patient has. And so a lot of this is hard to do, but terminology is often the key. Polyhierarchies, formal definitions are two of the things that can help you with this. So for inferencing and that sort of thing, I'm not going to try to go through this. I'm going to show you what we can do with the terminology. So this is an old shot of an early web-based clinical information system. What was neat about it was that we put in a de-explain button. De-explain is a program that does differential diagnosis, but you can't put in sodium 141, potassium 542. It doesn't understand that. But you can map those things to things like hypokalemia, hypocalcemia, those sorts of things, and it'll understand those. And so we put in a de-explain button, and then we took the lab terms using the terminology, mapped them to findings that would be recognized by de-explain, and then pass them off to de-explain. So with one button click, you could get a differential diagnosis of all your lab data, which if you tried to do it by hand, take you 15 or 20 minutes and give you this differential diagnosis. Now, the way we did that was we had a terminology. We could go from something like a serum cholesterol test and know that it mapped to serum, and we knew that it also mapped to cholesterol, and we knew those things mapped to abnormalities of serum cholesterol, which in turn mapped to hypercholesterolemia. And so we had a way to actually traverse from the lab term through the semantic network to a concept recognized by de-explain. So that's the short explanation. And we started doing that with other things and built info buttons for our web-based system. This is a now defunct web-based system. Was phased out a couple of years ago after 15 years of service. But the info buttons, pictures are still useful. So there's an info button next to K for potassium, and it generates all these questions. And each of these questions takes you out to some resource that doesn't know what K is, but it knows what potassium is, or potassium test, or hyperkalemia. It knows the concepts we can translate to and pass it off to these other resources. And I'm not going to go through all these, but you'll have these slides. So basically, just showing you what it does as you click on each of these buttons. The allergy example, I will show you that. We can write a rule that says, well, if the patient's on buffer, is allergic to bufferin, and we are going to order enteric-coated aspirin, you should send a warning. Well, you've got to know a lot. You're going to have a lot of rules to handle every possible permutation. And so one of the ways you can do it is instead use a knowledge-based approach that says, I've got bufferin, I've got enteric-coated aspirin in a hierarchy of aspirin preparations, and I know they have the ingredient aspirin. And so I can say, hey, if the patient's allergic to bufferin and I'm ordering enteric-coated aspirin, do a very simple check to make sure that none of the ingredients of what I'm ordering is an ingredient that he's allergic to. All right? And so if I do that now, I can say, well, what's he ordering? He's ordering enteric-coated aspirin. What's the ingredient? Aspirin. Is he allergic to aspirin? Well, he's allergic to bufferin, and aspirin's as an ingredient in bufferin. That seems like a complicated thing to ask a computer. It's actually quite simple to ask it to traverse those things in that particular way. And it could say, hey, the patient's allergic to bufferin, which is an ingredient of aspirin, which is an ingredient in the drug you're ordering. Maybe you want to rethink this, or don't order it, or whatever. So we can handle that through the terminology. So lots of data types, some of which are text, some of them are numeric, some of them are signals like images, cardiograms, but we can turn those into text. But eventually we turn it into coded data. Some of it's structured, coded, and we can use natural language processing to go from the structured text to the coded. We can do manual processing, and maybe we can get it to standard codes. And these things are blobs. The computer can store them and move them around, not blobs like big logical objects, but just blobs of data that can move around. You can ask it, it'll give it to you. It doesn't know what they are. But these things are the symbols that it can actually do logical operations on. So that's what we're trying to strive for. And that's where the terminologies come in. I won't go through this graph, but this is how are the different terminologies doing with respect to the different desiderata. So I've got a key at the bottom, and you can go and look up and see. ICD does pretty well with coverage. Well, it's really easy to do that when you have a code that's 999.99, disease not elsewhere classified. Well, there you go. You've got a code for every disease. So it doesn't do well on any of the other things, pretty much. Whereas you look at SNMD does pretty well. It's got some coverage problems, but mostly does really well. And then this is choice of terminologies. If you're trying to do a particular domain like labs, pick WOINC. If you're trying to do medications, pick RxNorm. If you're doing a lab test, pick WOINC. And diagnoses, pick SNMD, and so on. So again, you can use this for reference. Take-home messages. So put cool words in the title of your paper. People will reference the paper. Desiderata. If you go in PubMed, you'll see after I published my paper, lots of other papers had the word desiderata in the title. The most important desideratum is it's about the meanings, not the names. The meanings of the terms of the things that we want to record, because that's what the computer is going to be able to manipulate. High level, low quality, high quality, and low quality terminologies. It's hard to say how high quality a terminology is, but it's pretty easy to say when one is better than another. And so we want to look at that using the desiderata. Size isn't the only thing. Just adding more terms isn't the solution. Structure is important as content, and maintenance is important as both of those put together, because if you don't maintain the terminology, it falls out of use. It becomes unusable. So if you have to choose a terminology, or hopefully you don't have to create a terminology, but can reuse somebody else's, look at the desiderata when assessing these and when maintaining them. Take-home messages on terminologies. Capture your data with high-quality terminologies, kind of an obvious thing. Avoid NEC. Use the NOS terms, the higher-level generic terms, and add text modifiers, because you can always recover the meaning if you maintain those text modifiers. Translate as needed, and remember UMLS is not a terminology. And finally, when you're trying to solve knowledge representation problems, look and see how you can use the terminology itself to capture that information. This lecture was boiled down from a 3-hour lecture, which was itself boiled down from a 1-semester course. So there's a lot of other things here that I couldn't really touch on. Hopefully you got a flavor of the idea that terminologies have qualities themselves that are worth paying attention to, and then have a number of resources, so different terminology places you can go and get terminologies. This is the NCI term browser, which is a really handy way to look at terminologies. And there's its URL, and that's what we'll talk. So how'd I do? Somebody left some 4 minutes. So questions here, and then let's see if there's anybody still online. Questions from online. No questions. Yeah, Tim.
I'm curious. ICD-10 and 9, all historical components, is so bad. What keeps it around other than building?
What keeps it? No. Well, so ICD-9, ICD-10 go back to ICD-1 and previous terminologies that eventually, when the World Health Organization came along, they wanted to maintain statistical classifications of causes of death. And they wanted to be able to look at that from year to year, and then as knowledge grew, they had to evolve it to a new version. They actually tended to do it every 10 years. So 1975 was ICD-9, and so they were up to 9 by then. ICD-10 in 1982. So yeah, so World Health Organization tried to do it every 10 years, although they lagged then when they hit ICD-10. In the U.S., they did it for financial reasons. So they wanted to be able to have a code that would correspond to a reimbursement for a disease. And eventually these were used for the diagnosis-related groups, which is a way of prospectively paying a hospital. Say, oh, you have a case of pneumonia, we're going to give you this much money. It doesn't matter how long you're in the hospital, it doesn't matter what drugs you use, we're going to give you this much money. And that was, the DRGs were a smaller set that were used, a few hundred terms that were created by bringing together groups of ICD-9 codes. So why are they so bad? Well, they don't think they're bad. They think they're good because they like having a strict hierarchy, because that way every disease is in one place and you don't have to worry about double counting. Because if you have, good pastures in two places, you go, how many kidney diseases you got? 10. How many lung disease you got? 10. How many cases of good pasture disease you have? 10. Like, wait a minute. I look like I had 20 lung diseases and 20 kidney disease, but I only have 10 cases, so what's going on? So they don't like that double count. They really like the NEC class because they always want to have a place to put the disease. It makes it very convenient. But they're not the ones that are collecting the data. And so we end up, collecting data for billing purposes that loses the level of detail that we want. And that's a big problem. But the International Class, the World Health Organization thinks ICD is hunky-dory because it meets their requirements. But if you go to them and say, gee, is it really cool that, the meaning of this term has changed? For last year, now the meaning has changed. And if you go to researchers who use ICD-9 codes, who were using ICD-9, and say, did you know that your meaning of your code changed from the time you started your study to the end of your study? The patients with this diagnosis, they're not comparable, and they go, la, 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 they don't want to know because it throws, ruins their data. But in fact, they didn't know that was happening.
What about country? Okay, so China, so it's a graphical code, or Japan, or with this pictorial alphabet, and it's just everybody kind of shoehorned into using English. No. So they have they have their own terms for these things, and a lot of times there's terms that don't translate. They use ICD, but they'll have their own versions. I don't know what they do in Japan and China, but in Australia there's ICD-A, and in Canada there's ICD-CA, or maybe it's an ICD-AU, but they have their own versions of these things. And they do that in China and Japan. They'll have they can have whatever name they want. Remember, the concept, it's about the meaning. And they have numbers, like we do, and they use the same codes. They just might have a different name and use a different character set for depicting that name. But the concept is supposed to be the same. Well, I wonder, for example, I've just seen a paper, that, at one point, some Native American tribe had like 5 different ideas, that, sexuality was a spectrum, and so they had actually like kind of 5 different classes, like he who kills things really well wears women's clothes or something like that. I mean, so they had, and I can't remember what the 5 categories were, but it was like, oh, that was a little, again, culturally, how does that influence how a hierarchy is put together?
Well, of course it influences. I mean, that's, they're not going to put it in hierarchies that don't make sense. But they're going to have terms that are going to be different, that are going to defy the classification. Now they come up with their own. But if they're using ICD, their mapping, they're going to say, well, we've got this really cool term that means something really useful in our culture, but we're going to map it to this crazy ICD term because we have to report to the World Health Organization causes of death. And they do the best they can. They report it, and they go, yeah, the data's kind of useless, but we do the best we can. But hopefully they don't use it for diagnosis. Okay, well, that's the end. I think hopefully this was recorded. That hopefully they'll give you the slides. And I think there were a couple of readings that Ian's going to pass out. Be sure to sign in on the board outside if you have it, so they have your attendance. Folks at home, any questions? I don't know if I can hear you, but I could see you if you type it in. No questions. Okay. Let me just see. So if somebody has a question, if you don't have a question and you're at home, drop off, and I'll know that you don't have a question.
What's an HL7?
What is HL7? HL7 is actually an organization, stands for Health Level 7. Originally started with creating messaging standards and has developed other standards. The standards for shipping information around. The 7 refers to the 7th level of the OSI ISO communication model, I guess, where the lowest level is like wire or fiber, optic fiber, but the top level is application, and health level 7 refers to the 7th level where they will be shipping around messages. So for instance, the way that lab tests will typically get to an electronic health record is they'll be put into an HL7 message and then shipped over. And the HL7 message will have segments that are like patient identifying information and insurance information, and there'll be something about what was ordered. It's called an OBR record. It'll say, well, we ordered a CBC, and then what are the observations? Well, there will be a row for the hematocrit, and one for the hemoglobin, and one for the white cell count, and so on. And then within there are fields. And some of those fields have things like LOINC codes. And so when we ship around a CBC, we know everybody who receives it goes, oh, I know what this is. This is a hemoglobin, or this is a hematocrit, because they all understand. Well, that's been a pretty successful standing. Yeah.
Does HL7 use a standardized terminology inside of those fields, or is D3 trying to adapt to?
So HL7 version 2, it's at your option. So they have recommended terminologies. Some fields have required terminologies. For instance, what the name of the segment is and things like that. And I don't know which ones where they actually impose required terminologies. There may be required choices of terminology, like you have to choose one or the other. The sender and receiver largely have to agree on what terminology is going to be in there. So I don't think they mandate LOINC, for instance. But so for instance, our lab system, I don't think doesn't use LOINC. They use their own local terminology, and then the receiving system has to know what that terminology is. Okay. Well, thanks for your attention. And if you have questions afterwards, those of you at home, Semantic Trick at uab.edu. You can send me questions. I'll be happy to